Okay, question 5 says Petra is organising a prom for her year group. It says the number of people attending the prom is likely to be between 20 and 30 people. 20 and 80 people, sorry. That's important that you show that on your graph then in that case. The cost of holding the prom at this hotel is as follows. The hire of the room is 100 quid, the food is 15 quid per person, welcome drink is £3 per person, and decorations is £2 per person. Draw a graph to illustrate the total cost of holding the prom for between 20 and 80 people. And look, it says it there again. Okay, so it's important that you have that. Now, I would recommend doing costs probably on the y-axis. That seems like the most obvious place for it, but it wouldn't really matter if you did it on the x-axis. And the number of people coming here. It's important that you label axes still when you're 14, 15, 16 as much as it is as when you're in year 7. Okay, it's important you actually label your axes. Some of you didn't do that, and it's worth a mark actually labeling these axes and actually having some numbers on them. So if we're going up to 80 and between 20 and 80, I would probably go up here in 20s. So 20, 40, 60 and 80. It's as if it's made for it. The answer is it probably is. Okay, so you're going to pay £100 per person plus, £100 no matter what. So if no one else comes, even if no one else arrives, you've got to pay 100 quid for hiring the room. And then every person is going to be paying £15 plus £3 plus £2, which is going to be equivalent to £100 plus 20 quid times by the number of people. Okay, now that's not a way that you should know how to write that already. That's just me doing some problem solving here because it is quite a problem solving type question. Now, I would try and relate that into the form that we have been taught when we're talking graphs, which is y equals mx plus c. The constant thing here is the thing that's not attached to x. So in this case, it's going to be plus 100 because we know that no matter what, even if no one turns up, we still got to pay 100 quid to rent the room. And then each person is paying 20 quid. So it'd be 20x plus 100. That's personally the way I would do it. It's not the only way to do it. From there, I would create an XY table. So this is effectively my cost, and then this is my spend, I suppose. So if no one comes at all, I have to pay 100 quid. I know that. If 20 people come, then it's going to be 20. Now you're actually paying £20 per person, so 20 times 20, well 2 times 2 is 4, 2 zeros would be, 2 zeros added onto that would be 400, then plus the 100 would be 500 quid. Then I'm going to do 40, and then I'm going to do 60, and then I'm going to do 80. So then 40 times by 20, so 4 times 2 is 8, and then it would be 800, add the 100 would be 900. And can you see now, for a very quick, nice shortcut, this has gone up by 400, then up again by 400, so I can just keep on adding 400 to find the remaining numbers. So my 80, for 80 people it goes up to 1,700, so looking at that, probably the most obvious scale to go up in here would be maybe 500s. So we'd have 500, 1,000, 1,500, and 2,000. I then need to go and plot all of these numbers. So when no one turns up, I've got to pay 100 quid no matter what. So scale, if you wanted to work it out, we've gone up 500 quid in 10 little mini squares. So that would be 500 divided by 10, which would tell me each mini square is worth 50 quid. So 2 of them must be 100. And then 20 and 500 is really nice to plot. 40 and 900, a shortcut for that would be going to 1,000, but then come back 2, would take me back 100 quid. And then 60 and 1300, so there's 250, so add up 50. And then 1750, there's come back one there. And your ruler should go through all of those points. If it doesn't, you've drawn it incorrectly, I would have suggested. And then you continue the line on to just by there on the graph paper, okay? Okay, so the next question asked for Petra to decides to share the cost equally between the number of people attending. Let P be the price paid per person, let N be the number of people attending the prom. Write down a formula for connecting the prom, people attending the prom. Okay, so N is the number of people. So we're going to have the price paid, P. Now everyone has to pay 20 quid, don't they? We know that from before, that we're paying 20 quid from the food, decorations and welcome drink. We've then also got that share of 100 quid that everyone has to pay. So we've got the 100 quid and we'd want to divide that by the number of people attending. And that's it. That's what the formula is. They're not particularly nice. It's 3 marks. That's it for 3 marks. Some people spot it really, really quickly. Others will look at it and think, oh, I've got no idea how to do that. Best way, if you're stuck, is to think, right, okay, well, let's say that 10 people were attending. Do some working with the 10, work out how much each person would pay. So we know that if 10 people attended, they'd all have to pay 20 quid, and then there's that 100 quid. What are you going to do with the 110 people paying? Well, they're all going to have to share the 100 quid between them, aren't they? So you're effectively doing the 100 quid divided by the 10 to work out for the 10 people, it would be 10 quid each. However, if it was 50 people who were attending, it would be the 100 quid divided by 50. They'd only need to pay £2 each, and so on and so on and so on. So that's what this statement here is saying. It's saying that 100 quid that we have to pay for renting the room, we divide it by the number of people attending, and then each person is also responsible for that 20 quid that they've all spent. And then for part C, it says hiring a larger room at the hotel. This hotel costs 200 quid. The cost per person and welcome drinks remains the same. If the total cost is 2,240, how many people attended? Well, the first thing we need to do is we need to take off that 200 quid, because that's how much the room costs. So we've got 2,440 quid that is left on what was spent on like decorations and food and drinks. We know it costs 20 quid per person. So if I divide that by 20 quid, that will tell me the number of people in there altogether. 2,040 divided by 20, well, the zeros cancel top and bottom, and then 204 divided by 2 would tell me there's 102 people there. Okay. Next question was working with some box plots. This was done pretty well, to be fair. A couple of you got confused what range was and what interquartile range was. I would go and write down all over these things what they were. So this is your min, this is your LQ, this is your median, this is your UQ, and this is your max. So that is quite clearly 5, that's quite clearly 20, 30, 45, and 55. And I'll do the same on the bottom one. So this min was 1, 15, and 28, and 45, and 50. Okay, so I'm assuming the top one is the top one there on the sheet, but just check that is the case. It is. To work out the range is the biggest, take away the lowest, so 55 take away 5, which would be 50. Its median I've already identified as 30. And its interquartile range, you need to know a formula for that. It's the upper quartile, take away the lower quartile. Okay, but you will have heard that somewhere before. You definitely would have seen it. 45 take away 20 would be 25. For Norbury, its range was 50 take away 1, so I'm looking at this table here, 50 take away 1, which is 49. Its median is 28. And its interquartile range would be 45 take away 15, which is 30. Okay. Iona is going on a holiday next April. She's hoping for good weather with hardly any rain. She decides to go to Norbury. Give a reason to support her decision, which includes values for both Norbury and Trevwen. Now, you have to actually do what they said in the question. So many of you did not do this. You've got to write down stuff that they tell you. It says include values for both of them. If I'm looking to go to this place, it says, where'd she go? She went to Norbury. We've got to choose a reason why that one's a better one to go to. So my reason would be go because the median is better. Okay, the median is less rain. So Norbury has a smaller average, and I'll put in brackets which average I've used. Smaller average, in brackets median, is 28 millimeters compared to Trevwen, which is 30 millimeters. Okay, that's it. That's all you have to do, but you actually have to answer what they've said in the question. Okay, next question. Now, this is something that we've looked at in class pretty recently, which is velocity time graphs. Okay, First question. Well, let's read the question first. It says she went for a bike ride. She started at 1400. The graph shows information about her bike ride. So here we go. She went off. Now we know that means slow because it's not very steep. Then it went faster and faster and faster. And then, oh, hang on, no, it doesn't necessarily. It means that she wasn't going as fast here. So she's going faster, faster and faster. She's maintained speed now because that's measuring her speed. And then she's slowed her speed down. And then she sort of maintained it and then slowed down to like a complete utter stop. Okay, which quarter of an hour period was her acceleration the greatest? So a quarter hour period that is the greatest, we're looking for it to be the absolute steepest that it is. And for me, that's this bit here. So I come down to there. You can see that's bang in the middle of 1400 and 1500. And quarter of an hour period would be up until this point here. And for me, that's quite obviously the steepest part of the graph. So I'd say it's 1430 until 1445. Now we're looking for the bit where she stops accelerating. So that means the graph has to be completely flat. So it's getting flatter and flatter here, flatter and flatter and flatter. And there, for me, that's where it's completely stopping by about there. Although it gave some, actually checking the scale, it wasn't giving some weird answers. So if that's 1500, we know that's 1530. So that must be 1515 because it's halfway in between half past and clock. So there, so I make that 3:15. So 15:15. Shan usually finds cycling at a velocity of 14 kilometers per hour very comfortable. Express 18 kilometers per hour very comfortable. Express 18 kilometers per hour into meters per second. Okay, well let's start changing things here. So we've got 18 kilometers would change to 18,000 meters. That's what K stands for. K stands for 1,000. Hours, 1 hour, we know is 60 minutes, and we know that there's 60 seconds in a minute. So that means we need to do 60 times by 60. So, and that's because we want to get this per second. So 6 times 6 would be 36, and add 2 zeros, there's 3,600 seconds in 1 hour. So then to work that out in meters per second, I would do 18,000. 18,000 divided by 3600, and that would be meters divided by seconds. And then I'm going to cancel 2 zeros there and there, and then 36 into 180. Well, if needs be, count them out like this down the page. But I know already that it's 5 meters per second. Okay, and you may already know that fact as well. Okay, for the next part, it says, using velocities at 1400, 1500 and 1600, calculate an estimate for the total distance that she travelled between 1400 and 1600. So this is using something called the Trapezium Rule. So what we do is we fire up lines to the graph from here to here. Now effectively, we're treating this as an area, and this is why it's not very accurate. You may get asked this in the sum. They might say, why isn't this an accurate form? And it's because we're actually going to find these areas. So area A, area B, and area C. And can you see with area A, I'm actually finding more area than I've actually got there really. Okay, but can you see with area C that I'm actually finding less area that's given there? And some would argue that looks roughly about the same. And it tends to sort of average out a little bit, but it's still not the best. It's still not completely accurate to do it this way. Okay. However, it is a mathematical method that you can use, although it might say, explain why this isn't very accurate. And you'd say, well, because I've found more or less area than I need to be. And if it said, how could you make it more accurate? Then we'd fire up lines more regularly and find more areas, and that would make it a bit more sort of, what was I looking for? A bit more accurate. Okay, so area A I can see is a triangle, so that is going to be base times height divided by 2. So the base of that is 1 hour, so we're doing it in kilometers per hour, so I'm measuring this in hours, not in minutes, so 1 hour, and then its height there, if I come off and read off the graph, now you've got to be as accurate as possible here. I'm starting to regret how much right I've got there. So that's 15 to 20. So the scale is, I've gone up 5 in 10 little squares, so each little square is worth 0.5. And that is 1 square up for me, so I think that's 18. So that's going to be base times height, so 1 times 18, all divided by 2, which is 9 kilometers. For area B, it's going to be, now that is a trapezium if you need it. The area of a trapezium is given, it's just by there, although your trapezium sort of like rotated around like that because the parallel sides are there and there on the sides. I know it already, so I'll just sub into it by here. It's going to be a half bracket of the parallel sides, so 18 plus, let's check this one here, so that's 15, so I've come down 2 squares, so that must be 14. And then we want to times that by the height, which is 1 hour again, okay? Now the best way to do this is do 18 plus 14, which is 32. Half of that is 16, 16 times by 1, is still 16 kilometers. And I just realised I was about to find more area than I need to. It says the distance between 1400 and 1600. Then I don't need any of this. They only wanted this area, so I didn't actually need to find that area. Okay. So then add those two things together. 9 add 16 is 25 kilometres altogether. I might show that I've done that. 9 plus 16 equals. Okay. Part E, it says, in this question you will be assessed on the quality of your written communication and the organisation and accuracy in your writing. Sian's estimated distance she travelled between 16 and 17 as 5 miles. Is her estimate, is Sian's estimate reasonable? You must justify your answer. Okay, so if we looked at that graph there, we know that first triangle there is, we know that is 9 kilometres. Now she said it's 5 miles, so I'm going to actually go ahead and work out that triangle anyway, because they're trying to get me to compare between kilometres and miles here. Okay, so if I looked at that, that's 14 and its base is 1, so I know it would be area would be 14 times by 1 and then divided by 2, which would be 14 kilometres. So I'm going to state now, because of this statement here, I'm going to explain what I'm doing. Let's say Sian's distance, Sian's estimated distance is 14 kilometres. So what I need to do now is change that into miles. Okay, now I don't think that is a very good estimate because you need to know a definition here. And I'll say how I've done that. I say using the trapezium rule, and finding, oh, hang on, I made a really silly mistake here. 14 times 1 is 14, divided by 2 is 7. Okay, well that's much more likely then. Okay, that's actually looking pretty good. Trapezium rule and find area under graph. That's what I've done. That's how I worked that out. So it's important that I explain that to the examiner because it tells me that I need to. Okay, now you need to know this fact. 8 kilometres is equal to 5 miles. That is a definition that you need to learn. So I would literally just say, I've learned this fact. I've learned this fact. And Sian is close to 8 meters. Is close to 8 kilometers. Look at her graph again. We found a triangle. We've cut out a load of area. I'm going to say, as the area I have found, cuts out, or I'm going to say, as the area I have found is smaller than Sian's area, in the last hour, I think it is likely let me move the camera so you can see what I'm writing, that she could have cycled 8 kilometers and 5 miles is a good estimate. Okay, next question. Okay, so this is all about histograms. So before we go too much further, I'd want you to be writing this triangle down in your exam straight away. So FD, got another double letter on the bottom, CW there, and F for frequency there. Okay, so it says, last year, how many of the fish caught had a mass less than 250 grams? So last year, now this is all about time, so it's obviously not that one there. Mass, kilograms. Okay, so 250 kilograms, that's 500 grams, that is, because that's in kilograms there. Sorry, you can't see what I'm doing. That's in kilograms, they've given me 250 kilograms. So that must be this one here. So this must be 0.25 kilograms, which is 250 grams. Okay, now I want less than that, so I'm interested in this bar here. Now this bar here I can see has a frequency density of 8, and it has a class width of 0 to 0.25, which is 0.25, which is also another way of thinking that, which is a quarter. Now looking back at that triangle I wrote before, frequency, so if I cover up the F, would be the frequency density times by the class width. So what I'd need to do to answer that question is say 8 times by a quarter, which is a quarter of 8 is 2. Part B. Last year, the final angler to catch their first fish did so after 3.5 hours. How many other anglers took more than 3 hours to catch their first fish? So now we'll look at the one with hours here. Okay. Now we're interested in taking more than 3 hours. So we're at that point there, and we're talking more than that. So we're interested this way here. So frequency density of this one, you can see, is between 0 and 2, which is 1. And then its class width goes from 3 to 4, which is a distance of 1. So the frequency would be 1 times 1, which tells you there's one person in this bar. Now, I've already been told how many other, can you see, put that in bold, how many other anglers took more than 3 hours to catch? Well, there's one person, which was him, so no one else. No one else other than him. Okay. Next bit says, the number of anglers taking part in this year's competition was 3 times as many as took part last year. How many anglers took place in this year's competition? Okay, so we need to work out the number in each bar here. Now, the nice thing with histograms is that the areas are all this, tell you the number of people. So I know 2 of those little squares that make up that sort of like bar on its side. It makes 1. Alternatively, you can keep on using this. So here, I've got 2 as my frequency density, class width of 1, 2 times 1 is 2. So I know there's 2 people in that bar. Here, we've got 6 and a class distance of a half. So 6 times by a half is 3. And then you may start spotting these things and not needing to do all of them. And that's because of the areas, but I'll keep on doing it properly. So 8 times by a half, which is 4. 10 times by a half, which is 5. 4 times by a half, which is 2. And then that last one there, which is one that I've already worked out. So then to work out how many there were in total, I need to do 2 plus 3 plus 4 plus 5 plus 2 plus 1. That makes 10. And then 10, 6, and 7. So 17 last year. And we're told there's 3 times as many this year. So I need to do 17 times by 3. So I'm going to split it or partition it and times it, so we get 30 and 21, which makes 51 in total. Okay. Finally, I think there's more stuff on the other side. The median mass of fish caught this year was 0.9 kilograms. What is the difference in kilograms between the median fish of this year's this fish caught this year? And the median mass caught last year. Okay, so the median mass, so we're back to the bottom one. Okay, so we need to work out how many fish there were in total here as well. So we know that there was 2 in the first one. So I'm going to write these on top then. So there's 2 there. And that's a quarter again. A quarter of 32 is 8. And then that's a quarter of 40, which would be 10. That would be a quarter of 24, which is 6. That's the same bar, so it's also 8. That would be 4, and then that one there would be what, frequency density of 4, and then half 4 because it's 0.5 would be 2. So how many have I got in total there? So I've got 2 and 8, that's 10, 20, 30, 40. There's 40 fish here. So the median would be the 20th fish. Okay, now it's important that I write that down here in this working as well. There'll be marks that are doing this, okay? So I'd say total fish equals 40. Therefore, I'm looking for the middle of that. I'm looking for the 20th fish for median. It will be too easy if it just dies like dead in the middle, but it may do actually. 2 and 8 makes 10, so that's the first 2 fish, that's the first 10 fish by here. And then add 10 again, there. That's my 20th fish, right at the end of that category, which is at 0.75 kilograms. So this year, or no, this was last year's, wasn't it? This is last year's. So last year's equals 0.75 kilograms. This year's, they told me this year was 0.9. 0.9 kilograms. So I need to work out the difference between them. So that'd be 0.9, take away 0.75. Nothing, take away 5 you can't do, so you borrow 1 from him. 10 take away 5 is 5. 8 take away 7 is 1. 0, so my answer is 0.15. Okay. Approximately 10% of the anglers this year caught their first fish within an hour. How does this percentage compare with last year's? So we're back to the time one. So how many have we got? So approximately 10% of the anglers caught their fish within 1 hour. How does this percentage compare with last year's? So we've got 2 within the first hour, and there's a total, I think there's 17 anglers last time, okay? So it's going to be 2 out of 17, but we don't want that to be out of 17 because they want it as a percentage, so I need to try and turn that into a percent, so I need to turn it into out of 100. So what's the best way to do this? Okay, well, you know when we times it by 3, we found out that it was out of 51. We times that by 3, so we times this by 3. Now out of 51, if I double that, I get out of 102, which admittedly isn't 100, but it's very close. And that would be 12 out of 202. So I'd say this is approximately 12%. Okay, and what does it say? It says approximately 10% of the anglers caught in their fish. How does it compare? You must show your working. I'd say it is a similar percentage. It's not the same, but this isn't really out of 100, and I can't work that out. You know, the proper way you do it is by doing 2 divided by 17, then times by 100, but you can't do that without a calculator, and that's why they've said approximately, okay? And finally, it says, do you think it is fair to compare last year's competition results with this year's competition results? You must give a reason for your answer. There's lots of different reasons for this. I mean, the main one that I think of is no, because there are far more many people. There are 3 times as many. As many people. But someone came up with a really good one, which is like the weather conditions could be different to last year, etc., etc., etc. Okay, there's loads of different reasons you could give there. Okay, next page, and nearly the last question as well. Okay, so it says circle true or false for each of the following statements. Selecting the first name on a class register will give a random sample. Now, to be a random sample, everyone's got to have a fair chance of coming up. And if I've got a really good chance of coming up, I'm like Mr. Ashton, but someone else with like a surname beginning with Z has got a very, very unfair chance of being selected, okay? So that would be false. The ratio of boys to girls in a school is 2 to 3. A pupil committee, the pupil committee of 30 pupils is selected using a gender stratified sample. There are 10 boys and 20 girls. That's not true. That would be a 1 to 2 ratio. They just said it's 2 to 3, so that's false as well. A telephone survey is carried out to find which political party people support. The sample of people surveyed is not a random sample. True or false? Well, that is true. I don't like that double negative though. That's true because they said that it's not a random sample. It's not a random sample because some people may not be in the telephone survey, okay? Or they may be, what's it called, like, there's a way of doing it where you just, like, don't have your name and address given out, but otherwise, unless you state, you actually have your name and address given out. A stratified sample always considers proportions of the population. Yep, that's true. That's the whole point of a stratified sample. So the example I gave in class, I think we've got 7 boys and 23 girls. If I just chose 7 people at random, I could just choose 7 boys by, well, it depends. If I'm doing it sort of like a lottery system, that would be really, really, really unlikely, but it could happen. If I think about it cleverly, I could say, well, if I want to have 7 people, then it makes sense I should have more girls than boys, so there's more girls in the class. And then finally, it says a random sample of people means everyone has an equal chance of being selected. Yes, I've just been banging on about that. Okay, that's exactly what it means. Okay, nearly the last question then. So it says the shaded part of the diagram shows the top surface of an engine part. Measurements taken by the motor engineer are that B to O to C, so that should be a dotted line there. B to O to C is 240 degrees. A to O, so that long distance there is 6, and then B to O is 3. So that means they're split into 2 sets of 3, so that's 3 and 3 there, and they're both the same. That's the same coming back this side as well. Okay. The length of the major arc AD, so A to D would be that one there, and the major arc means it's the long one. This would be what's called the minor arc because it's smaller and it's not even there, okay? The major arc A to D is sealed by attaching a flexible anti-rust strip. Each flexible anti-rust strip is of length 35 centimetres. At what length of anti-rust strip will be left over after sealing the major arc of AD? Give your answer in terms of pi in its simplest form. Okay, so it's asking me to work out this length here. Now this length here is part of the circumference, so you need to know this formula. Circumference equals pi d, or circumference equals 2 pi r. They're both the same formula. It depends which one you've been taught and which one you prefer. Okay, I actually teach both of them, and you can make up your own mind which one you want to use. Okay, so I need to go and work out what the circumference of the circle is, and to do that I need to do that of the major arc, so that's the full thing there, isn't it? Now that is a distance of 6, which is the radius of 6. So I'm going to say radius AD arc length. Let's start off by here. Radius equals 6 centimetres. Okay, I'm happy with that. That would be all of that. That would be the radius. Now, to work out the circumference, I would do 2 pi r, but I haven't got the full circumference here. I've got 240 degrees out of a full circle. So I'd say, therefore, AD arc, I could say major arc, is equal to 240 out of 360 times by 2 pi r. Now, I'll just write 2 pi r for once, but I could just go and chuck in that 6 there if I wanted to. So I will chuck that 6 in. Let's do some cancelling down here. 0 and 0 cancel. 24 and 36. 12 goes into both of those, so that'll become 2/3. Times by 2, times by pi, times by the radius. Okay, so what we're going to do now is we're going to multiply these out. So the numerators, the things on the top, will times each other, and then we'll divide the whole thing by 3. 2 times 2 is 4. 4 times 6 is 24. 24 times by pi would be 24 pi over 3, which is 20. No, it's not. It's 8 pi. Okay. Now, if I was just to do a very, very quick calculation here, it says leave your answer in terms of pi, which is great so far. If we just said pi was around about 3, I know it's not, it's 3.14, but if we said it was 3, then that would make this about 24 centimetres. The strip was 35, and that's good because it's saying there should be some of the strip left over, okay? So it's just a little mental calculation. Now, if it was 24 centimetres, so I'll put in brackets 24 centimetres, to work out the length that would be left over, it would be 35 take away 24, it should be 11, wouldn't it? Happy days, we can do that, no problem. But we haven't really got 24, we've got it as 8 pi. Well, that's my answer then, it's 35 take away 8 pi. Okay, and that's how you'd leave your answer in terms of pi. Final bit then, it says the top surface of the engine part is to be painted. The paint costs 15p per centimetre squared. So that means we need to go and work out what the area is. Give your calculate the cost of the paint to use. Give your answer in terms of pi in simplest form. Okay, so it's still 240 out of 360, but this time we're talking centimetres squared, so we're talking area, and there's only one formula for this, which is pi r squared. Now, to work this out, I need to work out the area of the entire circle, but then I want to take away the mini circle inside. So I'm going to leave that there for now. I'm going to do some working out here. I'm going to say shaded would equal big take away the small. So that is going to be pi r squared of the big radius, which is 6. So it's going to be pi, and I'll put in brackets 6 squared, take away pi, and the radius of the small one is 3 squared. 6 squared is 36 pi, and then 3 squared is 9 pi, and then 36 pi take away 9 pi is 27 pi. Okay, so to work out the area of what's left, that would be of the entire circle. I don't have the entire circle. I have 240 out of 360. So that would be times by 27 pi. Now, in terms of that, we've got to try and simplify that down. So again, we can cancel that and that. That became 2/3 last time, times by 27 pi. 2 times by 27, or we could say how many 3's go into 27, which is 9. And then 2 times by 9 is 18 pi. Now that's going to give me the area in centimetres squared. And then I know that every centimetre squared costs 15 pence. So I might turn that into pounds. So I could say it's either 18 pi times by 15 pence and work out that way. In fact, actually, that probably is easier. Or I could have done 18 pi times by like 0.15, which is maybe not quite so obvious. So if we go and work out, so again, I did this earlier, I'll do it again. So I'm going to split it into 10 and 8. And then 10 and 5, so that's 100, 80, 50, 40, so 190, 270, 270 I think, let me slow down, 180, 220, yeah, 270, 270 pi pence. Finally, using pi equals 3, calculate how much it costs to paint the top surface of 20 engine parts. So we know for one engine part, it's going to be 270 times by 3, and the answer will be in pence. So what's that? So 27, 200, so let's set that out. So that's making me do loads of these, isn't it? 0 times by 3 is 0, 7 times by 3 is 21. 2 times by 3 is 6, add the 2 there is 8. So we know it costs 810p for one part, and they want it for 20 parts. So let's turn that into pounds now as well. So then it's going to be £8 times by 20, and it's going to be 10p times by 20. Well, 10p times by 20 is £2. 8 times by 20 would be 160, so 162 quid.